When a skydiver jumps out of a plane at 3,000 metres, her speed goes through some explain how all these changes in speed occur, you need to think about the forces involved. So what's happening to the forces as you fall through the air? The force of gravity is always trying to pull us towards the Earth. Before the skydiver jumps, the floor of the plane provides a counterforce which balances the downward force of gravity. Right? Gravity immediately pulls her towards the ground and she starts to accelerate downwards. But air resistance is acting in the opposite direction. The faster she falls, the greater the air resistance. Eventually, the upward force of the air equals the downward force of gravity. When forces are balanced, the speed remains constant. That doesn't mean she's stopped falling, it means she's stopped accelerating. She's still doing a steady 55 metres per second, and hitting the ground at this speed isn't a good idea. To slow down, the upward force needs to be greater than the downward force. When the parachute opens, air resistance suddenly becomes much greater than gravity. The forces are no longer balanced, and this changes her speed. She slows down. Because she's slowing down, air resistance decreases until it balances gravity again, and she reaches a much slower constant speed. Approaching the ground at 5 metres per second is a much better idea. As she hits the ground, there's a thumping great counterforce from the Earth, which decelerates her very quickly. So, for skydivers to land safely, they need to understand forces and use air resistance to slow themselves down.